Question 5. The label on a jar of Amy's jam states that the jar contains about 400 grams of jam. For each jar that contains less than 388 grams of jam, Amy will be fined £100. And if a jar contains more than 410 grams of jam, then Amy will make a loss on that jar. I guess because she's giving away too much jam for how much it cost her to make it. The weight of jam, A grams in a jar of Amy's jam, has a normal distribution. So A is distributed normally with a mean of mu and a standard deviation of sigma. Amy chooses mu and p so that the probability that A is below 388 is 0.001. Notice that probability is a very specific, neat and tidy one. And also the probability that the weight of jam is over 410 is 0.0197. And part A says find the value of mu and the value of sigma. So let's create a drawing for the distribution of A, normally distributed, but we don't know what the mean is or the standard deviation. But we do know that A being less than 388 is so tiny. So 388 must be down here, and this section here is 0.001. And so that's a 0.1% chance, and over on this side will be tiny as well, although bigger than that section. We'd have 410 over here, such that this section was 0.0197. So we can look these probabilities up for the standard normal Z, and then we can link those numbers to the 410 and the 388. So for the one on the left, we need to look up a probability of 0.001. And as I mentioned, because it's such a nice, neat probability, you want to go to the small probability table. And when you find that probability, it reads the Z value as 3.0902, but that's because it's reading from the right. Remember that the mean on this distribution will be 0. So we want to put this in as negative 3.0902. Now this probability, which is much more messy but has 4 decimal places, will come from the big table. So we're looking in the right hand column for 0.0197. Well, of course we can't actually look that up. We'll need to look up reading from the left. So if we work out what 1 take away 0.0197 is, which will be 3089, this is the number that we want to look up in the table actually. So that's 9803 there, 2.06. So over here we've got 2.06. So now we're ready to set up some equations that link these numbers together using mu and sigma. So we can say that if we took 410 and subtracted the mean and divided by the standard deviation, we would get 2.06. Or if we took this value of A, subtracted the mean and divided by the standard deviation, we would get this. So the simplest way to solve these equations is that we will be able to have mu's that we could equate. So if I take equation 1, let's move this up a bit so you can see what I'm doing, and we edit this equation a bit, we could actually, I won't put that, oh okay, no, I will, otherwise you won't know where it came from. So going from here, I'm going to take 410 minus mu and multiply the sigma up to the right, and then bring the mu onto this side and bring the 20.06 sigma to that side, and let's call this one double dash now. And then if I take this equation 2 and I do some editing to it, multiplying by sigma will get me this. then bringing mu to the right and this over to the left. I haven't quite left enough room for it really, I'll have to write a bit small. 388 plus 3.0902 sigma will give mu, and let's call this 2 dash dash. Now we can equate these because they're both equal to mu, so we can write here 1 dash dash equaling to 2 dash dash, and this is what we can write now. 410 minus 2.06 sigma has to equal 388 plus 3.0902 sigma. Now we can collect sigmas to the right by doing 3.0902 plus 2.06. So that's 5.1502 sigma. And then subtracting 388 from both sides, that's 22. And then sigma will be 22 over 5.1502 divided by 5.1502, and we get this 4.2716 and so on. So if I give sigma to three significant figures, that's 4.27. Now really I should be continuing to work underneath, but so you can see what I'm doing on the screen, I can come over to here and I can substitute sigma into, now I could pick either of these, it won't make any difference at all, so let's pick 2 double dash, and then I can say that mu would equal 388 plus 3.0902 multiplied with 4.2716. We want to use the accurate one. So now I'm going to type 388 plus 3.0902 times answer, and then I get 401.200 and so on, and that is 401 to three significant figures. So now part B. It says here, Amy can sell jars of jam containing between 388 grams and 410 grams for a profit of 25 pence per jar. Calculate the expected amount in pounds that Amy receives for each jar of jam. So when we think about what could happen to Amy, in terms of the money that she makes, I'm going to call it M, there are really three different things that could happen. It told us earlier on in the question that if there's less than 388 grams in the jar, then she's going to be fined £100. So that would be a case where she would lose £100. That's one of the things that could happen. If she makes somewhere between 388 and 410, then we're told now she'd make a profit of 25 pence. Or the other thing that happened was if she made too much, if she made A over 410, then she was making a loss on those jars of 30 pence. So this is like a discrete random variable situation in a way. There was three different things that could happen, and if we want to work out the expected value, then we want to know what's the probability of M taking a particular value of M. Really, I should label this little m actually. These are the particular values of how much money she would make, where capital M is the discrete random variable of how much money she makes on a jar of jam. So now I need to work out these missing probabilities. So let's think about what we know from before. The probability that A was below 0.388 and therefore that she loses £100 was this, 0.001. And the probability that the jar has over 410 grams was 0.0197. And so the remaining probability in the middle must be whatever makes these add up to 1. So I can do 1 take away 0.001 take away 0.0197. 0.197. So let's put that in the calculator. 0.197, and that gives me 0.9793. So now when I think about what's the expected amount of money that she makes, I just weight each of these things by the chance of them happening. So, okay, making negative £100 is bad, but it only happens very rarely, 1 in 1,000 times. Making 25 pence profit happens almost 98% of the time. And making a loss of 30 pence happens about 2% of the time. So then if I put this into the calculator, I will find the expected value of M. So having typed that in, that's giving me precisely 0.138915. So what does that mean in money? It means that she's making approximately 14 pence per jar. So I know we normally give 3 significant figures. I've written it out in full in case that's what the examiner wants, but to interpret money we would really give 2 decimal places for money, the same way that we do in the GCSE exam.